Good morning, everyone. Today, I'm going to discuss the continuation of the last class. That is, we are discussing the decision tree ID3 algorithm. So, I'll discuss today with an example. So, this is a given data set where we have four attributes: outlook, temperature, humidity, wind, and there is a class label. This is a class label, or else we can also say that it is a target label where we have two values. This is binary classification, that is yes or no. Let's see how I hope you'll remember that for implementing the decision tree algorithm, we require two things. That is, one is information gain. We have to calculate information gain, and we have to calculate the entropy of whole data set and entropy of the each individual features. So let us discuss these two things with this example. So what is this is an information provided like these are the days, and when outlook is equal to sunny, temperature is hot, humidity is high, and wind is weak. Whether we are going to play tennis or not is no. Likewise, according to these values and depending upon these attribute or features, it is going to give us the target class as whether we can play tennis or not, yes or no. Now, let us take the first one, that is outlook. The very first attribute is the outlook. So, we have taken the attribute outlook. And what are values in this outlook? Once you look at this column, in this outlook, we have a sunny, overcast, and rain. The same thing over sunny, overcast, rain. The very first thing is we have to find out the entropy of the whole data set. That is, entropy of S represents the whole data set. So, S equal to, I have written here 9 plus and 5 minus. So, what it is when you count these rows, we have 14 rows. That's why 9 plus 5, 14. And in this C, you see 1, 2, 3, 4, 5. 5 no is there. When 5 no, remaining 9 are yes. So that's why I have written here 9 plus 5 minus. And entropy is, you remember that minus P log of base 2 probability of yes, log of base 2 probability of yes. That is, yes is 9 by 14. 14 is total number of labels. So 9 by 14 log of base 2 9 by 14 minus no, minus probability of no log of base 2 probability of no. That is 5 minus. So 5 by 14 log of base 2 5 by 14. So when you calculate, you will get a value 0.94. Just cross to calculate these values. I hope you know how to calculate the log values. Calculate these things and check whether you have got the answer as 0.94 or not. Now, let us see, look at the values inside the outlook. So, we'll take sunny. So, how many sunnies are there? 1, 2, 3, 4, 5. Total 5 sunnies are there. And in this total 5 sunnies, we have 2 no's, 3 no's, and 2 yes. That's why I have written here as 2 plus 3 minus. Okay. Now, entropy of this S sunny is, so 2 whole thing is 5. That's why minus 2 divided by 5 log of base 2 2 by 5 minus 3 minus 3 divided by 5 log of base 2 3 divided by 5. So, we'll get a value of 0.971. Similarly, let us go for the other value in this outlook, that is overcast. How many overcast we have? 1, 2, 3, 4. So total 4 overcast are there, and in that also you look how many yes are there, how many no are there. So when we look that only 4 yes are there and there is no minus, so we given as it as 0 minus. And when you calculate the entropy, and remember, whenever we are calculating log of base 2 with 0, na, it will be 0 only. And when we have equal, let's calculate this. Minus 4 by 4 log of base 2 4 by 5 4 by 4 minus 0 divided by 4 log of base 2 0 divided by 4. So when one thing is 0, automatically it is going to get as 0. So this entropy of this overcast is 0. Next one is rain. So rain, we have 1, 2, 3, 4, 5. Total 5 values are there. And in this, we have 3 yes and 2 minus. That's why I have written here 3 plus and 2 minus. That is minus 3 divided by 5 log of base to 3 by 5 minus 2 by 5 log of base to 2 by 5. So the value is 0.71. So now the next thing is we have to find out the entropy of the whole data set. So I hope you remember the formula. Entropy of whole data set is given by, sorry, not, we already find out the entropy. Now it's, we have to find out the information gain. We already find out the entropy of the whole data set, and we also calculate the entropy of the each individual features. Now the next thing is we have to find out the information gain. So information gain formula is entropy of whole data set minus weighted average into entropy of each feature. So let us see how we are going to find out the entropy information gain of this one. So information gain of the first attribute is outlook. For that, so information gain S is whole data set of outlook is equal to entropy of whole data set, that is S, minus summation of sunny overcast rain, that is S of V divided by S entropy of S of V. That is, so how we are going to write this one is weighted average into entropy of each individual feature. That is what the formula. So entropy of S we know already, minus, so let us take sunny, that is, in sunny, how many sunny values we have? 5. 2 plus 3, 5 we have. So that is 5 divided by 14. Entropy of S sunny. We already find out the entropy of S sunny. Similarly, minus, now overcast. We know that overcast we have 4 values. So minus 4 by 14 entropy of S overcast. Minus entropy of this rain. So rain we have 5 values, 3 plus 2, 5. So minus 5 divided by 14 entropy of S rain. That is this value. Just substitute all these values into this formula. So entropy is 0.94 minus 5 by 14 into entropy of S sunny is the value. Minus 4 by 4 into 0. Why? Because we got S overcast as 0. Minus 5 by 14 into 0.971, which is entropy of S rain. So we will get a value of 0.2464. So the information gain of this outlook is 0.2464. Just make a note of this value. Then similarly, we are going to find out the same procedure we are going to follow for the temperature, humidity, and wind. In temperature, we'll calculate for hot, mild, cool, and how many yes, how many no. Find out the entropy of whole data set we already find out. So just entropy of individual data features. And coming to the humidity, we are going to find out the values for high and normal. Wind, we are going to calculate for weak and strong. How many weak are there, how many strong are there, and in that how many yes are there, how many no are there. Like that, calculate for temperature, first one. These are the values. Pause for a minute and check whether you have got the same answers or not. And this is the information gain of a temperature. And do calculation, just don't copy. Try to calculate all these values. So this is the information gain of temperature. Similarly, for humidity, we found high and normal. How many in high, how many yes, how many no, and normal, how many yes, how many no. Similarly, information gain of this humidity, that is, we got it as 0.516. Just make a note of this. And then last one is attribute wind. We have strong and weak. And how many strong? 6 strong. In that 3 plus 3 minus, weak 8. We have 8 plus and 2 minus. And this is the information gain of wind. Finally, we got, these are the 4 information gain of outlook, temperature, humidity, and wind. In this, once you look at this, so which is having the highest information gain? Yes, of course, we have outlook is having the highest information gain. So this outlook, we are going to take it as the root node. So how we are going to draw a decision tree is, see, outlook. So outlook, the total outlook we have D1 to D14 in this 9 plus 5 minus. And coming to the outlook, we have sunny, overcast, rain. So we have written sunny, overcast, rain. And in sunny, you check here how many sunny values are there. So sunny we have D1, D2, D8, D9, D11. So the same thing I have written here. D1, D2, D8, D9, D11. And in this, we have 2 plus 3 minus. Means we have 2s, 3 minus, where we can't decide yes or no. Why? Because we don't have equal numbers. So further we have to split this particular attribute. Then coming to the overcast, look at this table. Overcast we have D3, D7, D12, D13. The same thing I have written here. So we have in this 4 plus 0 minus. That means we have only one outcome, that is yes. So it has reached to the leaf node. It has reached to decision node, that when outlook is equal to overcast, yes, what is the outcome is yes. So we need not to further split this particular attribute. Then coming to the rain, you can see in this one, rain we have D4, D5, D6, D10, D14 noted here. In this we have 3 plus 2 minus, that is 3 yes, 2 no, where we can't decide whether it is an yes or no. Again we have to split this nodes. So this is one we reach to final decision, but these we have to still split these attributes into further. So let us see how we will continue further splitting of the decision tree. Now, coming to the temperature. So the very first one here is, we have sunny. Sunny we have D1, D2, D8, D9, D11. Only that particular table I have taken, removing outlook. Just try to understand here. Now, I am calculating this left hand side part, and I have only these 5 rows, D1, D2, D8, D11. That only I have taken here, and removing outlook attribute, temperature, humidity, wind, plate tennis. So for D1, whatever the values are there, these values I have written over here. Similarly for D2, from the existing data set, we have constructed this small data set for these values. Now here, again the same procedure we have to follow, that we have to find out the information gain of temperature, humidity, wind. That is, see here. So in temperature, we have 2 hot, 1 mild, 1 cool. The same thing I have written over here. So entropy of this head. So this is, as the sun is, entropy of this temperature is, we have 5 in this 2 plus 3 minus. So this is the entropy of this particular temperature. Okay. So we got it as 0.97. This is the entropy of the whole data set. Now similarly for hot, 0 plus 2 minus, and for mild 1 plus 1 minus, and for cool 1 plus 0 minus. In that way we find the entropy of S hot, S mild and S cool. And we know that the gain of now sunny with the temperature. So entropy of this whole set is 0.97 minus entropy of this S hot, mild, cool. So the whatever the values we got here. So at last we got information gain of this particular attribute temperature under S sunny is, we got it as 0.570. So next one for humidity. Similarly, we'll find it for the humidity. Again, humidity we have 3 high, 2 normal. In that 3 we have 0 plus, only 3 minus, 2 plus, 0 minus. When there is 0, or when you find out the entropy, you will get the value as 0. And substitute these values here, and we will get information gain as 0.97. Next one for wind. Wind we have 3 weak, 2 strong. And in this 1 plus 1, and when you have equal 1 plus and 1 minus, now remember when you calculate entropy, you will get 1 as the answer. S weak 1 plus 2 minus. So this is the entropy of S weak 0.918. And substitute these values. So gain of this wind is 0.0192. So when we see all this information gain of temperature, humidity and wind, we got highest for humidity. Now here we got a one variable called as humidity. Okay. So for humidity, you check here for humidity, we have 2 values, that is high and normal. And for high, we have only 3 no. Okay. And for normal, only 2 yes. So what we can decide is, when humidity is high, we got a solution, no. We have got a decision. And when humidity equal to normal, we got a decision as yes, as per the given data set. By seeing this, so we reach to a decision that when outlook equal to sunny and humidity equal to high, plate N is equal to no. When outlook equal to sunny and humidity equal to normal, then plate N is equal to yes. And when outlook equal to overcast, yes, you can plate N is. Now one more is remaining is when outlook equal to rain. What are the decision we have to take? Now what we have to do is, now in the data set, take these values. Take these rows of values. Now we'll see that. See, now here D4, D5, D6, D10, D14. Now for this, we have to find out the temperature. The same way, similar like earlier. So in temperature, we have hot 0, we don't have any hot. So mild we have 2 plus 1 minus, cool we have 1 plus 1. So it is 0, it is 1, it is 0, this one. Substitute in this and you got the information gain of this particular temperature, this one. Similarly for humidity, we have high, normal. In high 1 yes, 1 no, and normal 2 yes, 1. So these are the values of entropy of these individual features. And we got an information gain of for this particular humidity under this rain is 0.0192. Next for wind, we have 3 weak, 2 no. So 0 plus 2 minus. So we got 0, 0 value, and this is the information gain for wind. Now, when you take these three values, information gain of temperature, humidity, wind under rain is we got and wind as the highest value. So now we can split the tree into rain as we are going to take it as wind attribute. And in wind, see here, we have got this one. In wind, we have 3 weak, weak and strong. So in weak, we have 3 yes. And when you have strong now, you have 2 no. That is, when you have a wind is weak, yes, you can play the tennis. When wind is strong, you can play tennis is equal to no. See here. So when outlook equal to rain and wind equal to strong, play tennis equal to no. When outlook equal to rain and wind equal to weak, then play tennis equal to yes. Now we have reached to the final outcome. So there is no splitting of the tree. Why? Because we have got the outcome. This is the leaf node. We have reached to outcome state. So this is how we are going to construct the decision tree. So now converting the tree into rules. So already I told you, so if outlook equal to sunny and humidity equal to high, then plate N is equal to. Similarly, if outlook equal to sunny and humidity equal to normal, then plate N is equal to yes. In this way, we are going to convert a decision tree into the rules. So this is all about the decision tree. And here the main thing is that calculating the entropy of whole data set, entropy of individual features, and from that we are going to find out the information gain. And we are going to split the tree until we reach to a leaf node where we are going to further we can't split that particular. Thank you.